Let's make a deal. If you just give me 2 minutes of your time, I'll turn a seemingly impossible combinatorics problem into a frightened, convulsing pile of jello. Just what is combinatorics? Basically combinations, permutations, ways to arrange things. Let's gain some insight as to how to approach these. Let's say we have 10 people on a deserted island. Is that carrot cake? So these 10 people decide to elect a president, a vice president, and a secretary. How many different ways can this be done? First, we need a president, and the people choose Sporty Spice. Now, how many options do we have for a vice? No, not 10 anymore, because we already picked one. We now have 9. And JT wins this election. And after the vice has been selected, we now have 8 people for choice of secretary. Mel B, the clear choice. You can see that for every choice of president, we had along with that 9 choices of vice, and then 8 choices for secretary. All in all, we would now have 10 times 9 times 8 equals 720 president, vice president, secretary arrangements. This is a perfect example of a permutation in which elements are ordered. So just remember, with a permutation, order matters. Moving on. Let's change the situation just a tad. Instead of electing a president, vice president, and secretary, let's just say these 10 people are now electing a 3-person committee. No titles this time. All 3 people in the committee have an equal say in dessert island developments. And the people have been asking for that caramel apple tree orchard. This is now a combination and not a permutation, since the order of the people on the committee does not matter. Remember, folks, in a combination, order doesn't matter. Before, we had Sporty as Prez, Mr. Timberlake as Veep, and Mel B as Secretary. And if it had been JT as Prez, Sporty as VP, and Mel B as Secretary, that would have actually been a different arrangement. In fact, there are 6 permutations with just those 3 people alone. However, notice that when the order, in this case the title or differentiation, isn't in effect, we have only 1 arrangement. In fact, for every 6 arrangements where order does matter, in other words, permutations, for combinations we actually only have 1. Divide that 720 by 6, and we come up with 120 total combinations. So that's the basics of combinations and permutations. But to really get to the center of this Tootsie Roll Pop, join us in video 2. Or if you have a comment on this video, please write below.